investigating resistance. Right, so what is the point of all this? What are we actually doing? At its heart, this experiment is all about figuring out what affects electrical resistance, what makes it harder or easier for electricity flow. It's such a fundamental idea in physics, so really getting it is absolutely crucial. Okay, so AQA gives you a couple of options here. You might be asked to compare totally different components, like a fixed resistor versus a light bulb. But for today, we're going to focus on the absolute classic version, seeing how the length of a wire changes its resistance. And the best part is, the physics and the skills we cover here will work for any version they throw at you. Okay, before we even think about touching a wire, let's make sure we've got the three key ideas totally locked in. Honestly, if you can get your head around V, I, and R, the rest of the practical becomes so much easier. First up, potential difference, V, which, let's be honest, you just call it voltage. Think of it as the push from the power pack. It's the energy that gets the electrical charges up and moving around the circuit. Simple as that. No push, no flow. Next, we've got current, which we call I. So if voltage is the push, current is the result of that push. It's how much charge is actually flowing. We measure this flow rate in amperes or just amps. And finally, the star of our show, resistance, or R. This is simply a way of measuring how much a component gets in the way of the current. You know, high resistance means it's a real struggle for the charge to get through. Low resistance means it's an easy ride. Now, listen up, because this is absolutely critical. This equation, R equals V divided by I, connects everything we just talked about. And here's the kicker. It is not on your equation sheet in the exam. You have got to know this one by heart. Resistance is potential difference divided by current. Say it again. You're going to use it for every single calculation in this practical. All right, theory's over. Time to get practical. This next bit, the circuit and the method, this is where the big marks are in the exam, so let's really focus. This is the circuit diagram. You need to be able to draw this in your sleep. Now, the most important detail, the thing you cannot get wrong, is how the meters are connected. The ammeter has to be in series, part of the main loop, because it's measuring the current flowing through the wire. The voltmeter goes in parallel, across the wire, because it's measuring the difference in energy from one side to the other. Getting these two mixed up is without a doubt the single biggest mistake people make. And here it is, the entire method in 6 easy steps. Think of this as your recipe for that perfect 6-mark answer. It's just a clear, logical story that the examiner can follow. You set up your circuit, pick your first length, take your readings for V and I, then you just move the clip, repeat the readings for new length, and keep going. And for each one, you calculate the resistance. It's that straightforward. Just collecting the data is only half the story. Now we need to turn those numbers into a proper scientific conclusion. You've got to present your results in a neat, tidy table. Make sure every column has a clear heading with the quantity and the unit, and that last column, the one for your calculated resistance, that's the golden ticket. That shows you're processing your data, and those are the values you're going to plot on your graph. Here's a little pro tip for you, a really easy way to pick up a mark. Just show one worked example of your calculation. Just pick one row from your table and spell it out for the examiner. Show them exactly how you used R equals V over I to get your answer. It's a simple way to prove you know what you're doing. You plot a graph. Your calculated resistance goes up the side, on the y-axis, and the length of the wire goes along the bottom, on the x-axis. And if you've done everything carefully, bam! You get this beautiful straight line going right through the origin. And that graph, that's your proof. That's what lets you write your conclusion. Resistance is directly proportional to length. The longer the wire, the bigger the resistance. Perfect. You need to evaluate your own experiment, think about where things might have gone wrong, and, most importantly, what you did to stop them from going wrong. Okay, so there are two main troublemakers when it comes to errors. First, you have random errors. These are just unpredictable little blips, like maybe you misread the meter for a second. The way you fight these is by repeating your readings and taking an average. Then you have systematic errors. These are more sneaky. They're usually from faulty gear, and they affect all your results in the same way. So if you want to show that examiner you really know your stuff, here's your checklist. These are the things they look for. Did you turn the circuit off between readings to stop the wire from getting hot? Did you make sure you were looking at the meter straight on, at eye level, to avoid parallax error? Did you repeat your readings? Mentioning these little details shows you've really thought about how to do a proper, accurate experiment. These are the few key things you absolutely need to remember about this practical.
Here they are, your 5 keys to success. Number 1, know that equation, R equals V divided by I. 2, get the circuit diagram perfect, ammeter in series, voltmeter in parallel. 3, know the conclusion, resistance is directly proportional to length. 4, be ready to talk about the key errors, especially heating. And 5, remember to control your other variables, like the thickness of the wire. If you can remember those 5 things, you'll be in a fantastic position.
And there we have it. You've got the theory, you've got the method, the analysis, and all the top exam skills you need to walk in and smash this required practical. The only thing left to do is get some practice in on past paper questions. You've got this. Good luck.